stops?
No.
Or they
So the gases are still traveling out. It's just the particulate matter that's trapped. Yeah. Yeah. So the gases still end up going out of the food. But yeah, we'll talk about that. So the second objective is to produce power. So that begins in the furnace. So essentially the furnace works like a giant kettle. Everything's burning. The whole furnace section here is covered in these tubes, water wall tubes. They all heat up and create steam. So we usually burn between 850 and 1,000 degrees Celsius. So it's hot enough to melt metals, but not hot enough to destroy them. And that ends up, causing a lot of issues here. Because remember I was talking about the grate system. So it ends up melting on the grates, and then it stops the grates from moving. And then we have to shut a stream down and then chip it all out and sort that out. The water that we use has to be ultra pure, and that's in order to preserve the life expectancy of the boilers and all of the tubes. We don't want any scaling going on. So there is a reverse osmosis plant on North Shore. I don't know if you guys have seen that. So they bring water in and purify it to a really high standard of drinking water. We then get the water from them and then completely demineralize it to use it within our system. We also have to remove oxygen from the water because that can cause damage to the tubes as well. So we have a de-aeration device. So most of the steam that we make gets sent directly to the turbine to run the turbine. Then we also have several pumps and auxiliary systems that are run by the steam as well. So everyone knows turbine works exactly like a windmill. It's just it's being turned by steam rather than by wind. Turbine's connected to our generator. Generator obviously is producing power. The steam that we've produced is ejected and then recaptured, and then we actually turn that steam back into water and then put that back through the system as well. Like obviously we've gone through all this trouble to create steam, we're not just going to dump it. Then so we cool the water basically by using seawater. So over on the North Shore we've got the seawater plant that brings cool seawater in. That travels up, it travels around several pieces of equipment. There's 4 pumps that we use, and they can pump over 1,000 cubic meters of water every hour, so that's enough to fill 150 bathtubs every minute. In order to keep the seawater pipes full of any organic growth, we have an electrochlorination plant, so we actually produce chlorine, inject chlorine into the pipes to keep them clear. And again, that's using a process, an electrolyzer process. This is a picture of the turbine generator here. It's kind of hard to see because it just looks like a whole bunch of pipes, but the seawater comes in, just runs around that equipment and then travels back out. So it doesn't actually come into contact with anything, so it's not contaminated. Obviously we don't want to send the water out to sea a lot warmer than when it comes in. We don't want to create any, thermal pollution at the outtake there. So we do have an environmental operating license that we fall under. But generally the seawater that goes out is maybe 4 degrees warmer than when it comes in. When we're running at full load, we can generate over 7 million watts of power. So obviously we're running ourselves. We actually run the reverse osmosis plant, which is next door. And then it's enough power to generate about 3,000 homes, or maybe 8% of the homes on the island. So it's not too bad. So obviously we're turning something that would ordinarily have become landfill into something more useful. So we're turning garbage into power. And because most of the waste that we burn is considered, biomass, it's wood, paper, food. It doesn't increase greenhouse gases like fossil fuels do. And we've already talked about toxic items that shouldn't go into the waste stream, because obviously when you see that bunker, once stuff goes in there, that's it. There's no way we're going to be able to fish it out. So it will end up getting burnt. So you're asking about the emissions. So we do produce obviously carbon monoxide, sulfur dioxide. One of the big ones is hydrochloric acid, because we are burning a lot of plastics. And NOx, SOx as well, and then we talked about the dioxins and the furans. So again, this falls within our environmental operating license. We're only allowed to produce, X amount of each gases. Everything's monitored, so like every 6 minutes there's a reading of whatever it is that, gas that we're monitoring. If we go over our environmental operating license, that has to be reported. If we can't fix what's going on within the combustion process, then, they can ask us to shut down. Lots of other waste to energy facilities, or I would say most of them, do have bag houses, where they would collect a lot of this, these gases. But several things. So when the plant was designed, obviously it was 28 years ago, so things have changed since then. And when additions are made to the plant or a new stream is created, there will be a different set of emissions controls. This is the right way to put it. But one of the reasons that wasn't put in the first place is, what do you then do with that material? Because there's loads and loads of lime and or charcoal and things like that that are used to capture these gases. And then where would we dispose of it? So that's one of the reasons why. When the plant was designed, the stack is actually 91 meters above sea level. So no matter which way the prevailing winds are, everything gets, so it doesn't land on the island. Yeah, unfortunately it still lands out to sea. So there is, still that element of pollution. But
do you know if are there any technologies out there that have been able to capture this in some way?
Yeah, there are. Yeah, I mean, obviously not 100%, but yeah, there's definitely stuff that's available now that can capture that. Yeah, and as Venice was touching on, for us actually sending hazardous materials overseas, it's quite complicated, and there's a lot of things that you have to go through. And obviously, the US is the closest place, but are they going to want to accept, let's say 20 tons of lime that's full of hydrochloric acid and that sort of thing? So,
what's the lifespan? How long do you expect
the plant to survive? Yeah. It's on its final days currently.
It's in a wheelchair.
It's a long time already.
It is a long time. Yeah.
It's almost 30 years old now.
Yeah. So right now we're doing some major work to prolong the lifespan, but it is, it's on its last legs. So.
And is there what are you thinking, or what would you?
Well,
if you could wishfully think, what would you want to happen?
Yeah, I think the ideal thing would be, so when the plant was designed, it was set up for 3 streams. So you would always have like a duty standby, but only 2 streams were built. So we do have space for a 3rd one. So ideally, the 3rd one would be built, and it would have, additional sort of pollution control devices on it with all, the latest technology. And then you would still have 2 streams that you can run and sort of bring up to snuff over X amount of time, and add additional, pollution controls devices and also just combustion controls. Because we didn't really talk about, so the single-use plastics, the country's trying to implement or sort of like phase out single-use plastics. So with the amount of plastics that are in our system, obviously it's great for combustion because it's just oil. So, we get a really good burn from all the plastics. If that is now reduced, we would have to change our combustion process slightly, in order to accommodate that. So.
I think single-use plastics, going back to the household-based items, the plastics are 17%, right? And I think I have actually done a breakdown of the plastics by number 1 and number 2 bottles. I separated those out: bags, styrofoam, and something else. And I think I want to say that those single-use plastics are like 15% of all the plastics.
Mhm.
So if there's only 20% plastics in the entire waste stream, and then only 5%
Right.
of that 20%. So it's pretty low actually.
Mhm.
It's not gonna knock out that much stuff, but what it's gonna hopefully do is get consumers to be more aware of what
Conscious.
they're doing.
Mhm.
And then it'll be interesting to see, yeah.
Mhm. Yeah. But obviously it's a government facility, and governments are always strapped for cash, so,
More so now than ever.
yeah, we're not sure what the future holds, I guess. We know what we need,
Back
and we
in
know
our
what the
burden.
country needs in order to continue and function, but, yeah. All right. Okay. Were there any questions? I think what we'll do, we might have to go in two groups, yeah.
What does the future of Bermuda's waste management strategy look like if this plan isn't either like brought up to speed again or like
Or-
goes offline?
Right. Yeah, that's a very good question. Yeah.
Is there like a plan or?
There is no
Above my pay grade.
Fair enough.
So cross your fingers and hope for the best type.
Yeah, I mean, yeah, we can't go back to landfilling.
Yeah.
That's
No,
just, you know, yeah,
And I
that's
guess the
impossible.
population's increased so much in the
No,
past 30
it's
years.
gone down.
It's gone
Population's
down,
gone
yeah.
down. Waste volume's gone down in the population.
I think that's the only thing that's actually
Yeah,
saved
yeah,
us is the
yeah.
actual reduction in waste between like now and
Yeah.
10 years ago.
And I
If
guess
we-
one thing.
Oh, I was
that
thinking
have-
30 years.
Yeah, one thing I didn't mention, and that is a lot of these technologies, like for example, what we're in now, they rely on a certain waste volume per year, right? And, you know, we have looked at other technologies over the years, and we don't make enough trash to actually support the system. We've got to have enough material in the facility. Most of them, the cutoff point is 100,000 tons of waste a year. We don't make anywhere near that in combustibles. What's our combustion, total combustion? It's nowhere near that.
No.
Because they've been
Yeah.
built
I'd say
to
the-
support much more design. to
Exactly,
support
design
Yeah.
much bigger, yeah.
The
communities, right?
highest we've ever had, I think, was like 88,000
That was
tons, and that was a long
tons
time
of
ago.
combustibles.
Combustibles.
Total that's combustibles, right? Yeah.
But that may have been
Yeah,
like
exactly, and that was.
2000
Yeah,
or
yeah.
something.
So we don't have as high a volume as you need for a lot of these systems. And, so it is a challenge for us what we would do.
Mhm.
It is.
Do you see anything from